computing. Join us to welcome Lakshmi, Soumya, Priyanka and Carol for a deep dive into securing sensitive data in the cloud. What a thought-provoking session it will be. So shall I welcome Lakshmi, Professor from Indian Institute of Management. Lakshmi, can we have you on stage, please? Oh, we are fixing the technical issues. Hi! Welcome, Lakshmi. Our second speaker is Soumya, advisor, software engineer from IBM. Hey, Soumya. Our next speaker is Priyanka Mehta, security engineer from Google. Hi, Priyanka. And Carol, technical marketing engineer from Cisco. Over to you, my lovely ladies. Thank you.
Thank you. Thank you. Good afternoon, everyone. Am I audible? Yes. Thank you for the introduction. And yes, I am Lakshmi Gunapudi. I am an adjunct faculty at IIM Bangalore and also a senior researcher at IIT Bangalore. And we welcome you all to the panel under the category Cloud, IoT and Cybersecurity. And the title of our panel today is The Future of Data Security, Confidential Computing. Right, and I'm very privileged to share the stage with these three very accomplished ladies, Soumya, Priyanka and Carol. Right, as we all know, cloud computing is very powerful and it offers several advantages to all the adopting organizations, which range from scalability, accessibility, reliability, right, performance, remote work, business continuity, innovation. Right. However, despite all the efforts, right, by leading cloud service providers, there are still several industries that are heavily concerned about data privacy and security issues, specifically public and hybrid clouds. Right. I'm talking about the industries which include financial services, utility, pharma, and healthcare. These industries primarily are heavily regulated on one side, and also the stakeholders often push back on cloud migration due to concerns about security, compliance, data loss, right? And given the rise of IoT technologies, we have created a new genre of attack services that could be exploited if not properly secured, right? While several techniques and technologies have emerged to secure data at rest and data in transit, one of the challenges that still remains is around data in use. Right, data that is being processed. If you ask me in 2012 when I was studying cloud adoption in organizations, and I was looking at managerial decision calculus on how they make these decisions about cloud migration, and while we were interviewing them, what I found was that information privacy and security came up to be one of the topmost deterrents to cloud adoption. Right, but it has been 12 years since, and a lot of technological interventions and regulatory interventions in the data privacy and security space. Priyanka, can we hear from you? What, according to you, is the current discourse, right, on data privacy and security among cloud providers and adopting organizations?
Sure, Lakshmi. Thank you for sharing the information. Hi all, I'm Priyanka from Google, working as a security engineer. So currently we everywhere talk about data, so securing a data is very important. And when we talk about the discourse of data security and privacy in terms of cloud providers along with the adapting organizations, so I believe it's a mutual shared model responsibility between both the cloud provider as well as the adaptive organization to work together to secure the data. There are certain rules and regulations that both cloud provider as well as the adaptive organization should follow. So basically I'll categorize it into some key considerations. First among them would be the regulation. So they need to follow the regulation from GDPR, which is General Data Protective Regulation, as well as from the CCPA. which is California Consumer Privacy Act. So they provide them with some protocols that they need to follow, and using those protocols we can apply security measures for them. Along with that, they need to maintain transparency between the data. Cloud providers are like, they are moving more and more towards the security encryption keys, more into the using more advanced keys for encrypting as well as decrypting data. Another thing that we can consider as a shared responsibility model is for creating a transparency between the cloud provider as well as the adaptive organization, so that it becomes the responsibility for both of them to provide security. So it's like, if we take care of the cloud providers, they need to maintain the security at the infrastructure level and the hardware as well as the networking side, whereas the adaptive organization, they need to take care of the data that being used, the data of the consumer that they are consuming or they are distributing or they are protecting. So that needs to be very secure. All this we talk is about the data that is in use, that is in transit either, or that is the data that is rest. But what about the data that we are actually using, the data that we are processing? So there comes the concept of confidential computing, which helps to secure the data that is being in use. So what we do there is we create some secure enclaves for the data, where we store those data into those secure enclaves, and which provides a compelling solution for securing data.
Oh, wonderful. So it seems like data privacy and security continues to play, if not the same role, much more important role today, right? So Carol, can you, elaborate on what are those set of practices, guidelines, and techniques which kind of form the least common denominator in confidential computing domain, and how are they assuring this confidentiality, right?
Thanks, Lakshmi, for the question. So, when you talk about confidential computing, the way it has evolved is, it's evolved from operational assurance to technical assurance. Now, when I say operational assurance, it's a company giving you assurance saying, I will not access your data. And what is technical assurance? The company giving you assurance saying, I cannot access your data. So this itself is a big difference, right? Now, if you want to picturize confidential computing, I have a great analogy here. So say you are entering into a busy library and you are reading a confidential document and you want to modify it, but you and the confidential document are totally invisible. So, say you're wearing the invisibility cloak from Harry Potter, or for Bollywood fans out here, maybe Mr. India's watch. So nobody knows what is happening. It's just you and, the confidential data that you're accessing. So what are the companies doing about this? Well, we do have something called as a Confidential Computing Consortium. So this is a collaborative initiative that is hosted by Linux Foundation. And its main aim is to accelerate the growth and adoption of confidential computing technologies. So it brings together different industry leaders. So you have your software developers, you have your hardware vendors, you have the cloud providers as well. So it has a couple of premier members. So Google, Microsoft, Intel, AMD, these are all the premier members. There are a set of general members. So I work for Cisco, and Cisco is one of the general members. And there's again another set called as associate members. And in Cisco, we do have a product called as Cisco UCS. So this is a server, or I would say a unified system, which brings together your industry level servers, your networking, storage access, all into one particular unified system. And this product has Intel SGX, so which is nothing but an extension of your x86 architecture, and it gives you this particular secure enclave, which Priyanka just mentioned about, and you can get the security that you want from confidential computing.
Perfect. So looks like industry has come up with a solution for this protecting data in use in the form of confidential computing. And as far as I understand, it is a technology on top of cloud infrastructure which provides exclusive control of encryption keys and delivers strong end-to-end data security in the cloud, right? Soumya, we have heard from Priyanka and Carol. What is your organization's take on confidential computing? And one more question, how exactly does your job role fit into the space of data security and confidential computing?
Yeah, Sure, Lakshmi. So before I start off with how my job role actually fits into the confidential computing, right? I will just tell what IBM actually has in confidential computing already in market and how I have been part of that product. So with IBM, right, it's started off with secure servers from early 90s, and IBM Z Systems is mainly known for its zero downtime, confidentiality, data integrity, right? IBM also started to invested into the confidential computing over a decade back, and it first launched its confidential computing capability in 2018, which is IBM Cloud Hyperprotect Services. IBM Cloud Hyperprotect Services covers a wide range of products. I will not go into each of them, but I will try to actually put in some of the pointers here. We have a virtual servers and also secure build environments and also signing services, and also we have other more services which also runs on Intel SGX. As Priyanka and Carol mentioned, it's a trusted execution environment Intel SGX provides, right? We have also virtual servers on top of that. Now let me come to my journey, how my job role actually fits into confidential computing. My journey with confidential computing started around 8 years back with IBM Secure Service Containers. So it is actually base for this hyperprotect virtual servers, which is secure server VM that runs on the IBM Secure Execution for Linux, which is a server that is built using the trusted execution environment. So we build the base OS and the capabilities that provides the securities for the secure workloads to run within these containers. The main speciality of these containers is actually even as IBMers or IBM cannot even retrieve any information from these containers without the consent from the vendors. We need a vendor key to even retrieve the logs to do the debug of any errors or issues. Even the configuration information, whatever we have within the secure workloads, it's really secure. Even the customer cannot view what is from IBM and the IBMers cannot view what is from the customers. That level of security that we provide from confidential computing. And I was also part of Hyperprotect Container Runtime Environment Development, which is basically a base for building up the VM that runs the secure workload. It is similar to Secure Service Container, but we have some more hardware support from the Secure Execution for Linux to support these environments. So I think I have answered your question, Lakshmi,
Yes,
on
definitely.
how we contribute to confidential computing.
Thank you. Very interesting journey, in fact. So, we often hear this term trust boundary, right, related to techniques of isolating and securing data. Can one of you elaborate on this trust boundary as we know about it?
Yeah, I can take this. So, see, when you say you're running something in a cloud, that's technically nothing called as cloud, right? It is just another person's computer. So, when you're running an application on the cloud, there is some amount of trust that you need to have. And what is this level of trust is something that is defined by trust boundary. So, you have VM level isolation, you have process level isolation, and then you have function level isolation. So what is VM level? So the whole virtual machine is in a secure enclave. And all the elements that are inside this virtual machine have access to the code, the data and everything. But the problem here is that your trusted computing base is quite big. It's the whole virtual machine. But it's helpful when it comes to shifting, say, legacy applications to confidential computing, because it's just lift and shift. You don't really have to modify the code. The next is the process level isolation. So your application is the trusted computing base, and this is also called as confidential application or confidential containers. And next is the function level. So the trusted computing base is the minimum. So the application is divided into different functions or subroutines, and each function itself is a secure enclave. So even if there is any untrusted code in your application, it has no access to this particular function. It's totally encrypted inside that. And but yeah, there is a disadvantage here because there is a lot of modification of code that is required. But yeah, the advantage is that the trusted computing base is small. So based on your use case, you'll have to choose which level of isolation you'll want to go ahead with.
Oh, that's nice. So there is a certain definition of what level of trust you want to implement. While that is at the definition level, what exactly is the technological fabric underlying the implementation of confidential computing? One of you.
Sure,
Control.
I can take this. So, confidential computing, till now we have already heard that we are protecting data that is in use. So, confidential computing basically it relies both on the hardware as well as the software techniques. So, if I talk in terms of the hardware, so let's picturize it like this. We have a physical server. So, let's carve it physically, the server memory, and all the applications that we have, let's give them a separate apartment in a building. These private apartments that we consider them as secure enclave. So these enclaves are nothing but these are the isolated memory regions within a CPU or a DPU or a GPU. Just in case to elaborate it, CPU is control processing unit, DPU is data processing unit, as well as the GPU is your graphics processing unit that we use for the AI/ML functionings. So what we do here is we have given separate apartments to each of our application, which we call as the secure enclave. And this enclave is very secure that nobody another from the one who does not have an encrypted key can get into this. Let's consider this as a VIP launch. So this VIP launch is nothing but we call this VIP launch as the TEE, which is Trusted Execution Environment. So this trusted execution environment itself acts as a secure place where your application and your data resides. Now the cool thing that comes here is the data inside the secure enclave is also encrypted. So as soon as the data gets into the CPU, it's encrypted, but it only gets decrypted when it is moved out of the CPU. So when it moves out of the CPU and it goes to the RAM, it is decrypted. So we can see we have a top level notch of security where we have a trusted execution environment which creates a secure enclave where our application and data resides, and data itself is also encrypted. So this is where we follow the trusted execution environment implementation. Now if I talk in terms of technical implementation, so basically it involves 3 steps. First one is the isolation, where the TE creates a secure enclave where all our data and application resides and no unauthorized user can access it. Second comes the encryption. The encryption on the data is done through several security key management tools so that nobody can decrypt that keys. And the third part comes is the attestation. So the secure enclave into which our data resides, that should be secure and it should be intended to do what it is asked to do. Not like sharing data with anyone, not either with the organization or the cloud provider, as well as with the insider employees who are actually working on to data. So this is where your data is very secure, and this is where the the confidential computing actually works out.
So this TEE seems to be one of the major techniques followed to implement confidential computing. Is it generally the only go-to method, or are there any alternate techniques which can strengthen this confidentiality further?
I will take this one.
Yeah.
So, yeah, true. Trusted execution environment is the key technology that is used to achieve the confidential computing, to encrypt or to ensure the data is secure in processing. But from my perspective, right, it is not just about trusted enclaves. Because if we see a building, right, we will have multiple level of securities to ensure it is completely secured, right? It is not just one entry at the main place. We have from the gate till the entrance of the door to the auditorium, right? So similar to that, not just the trusted enclave which sits inside the hardware plays a major role in confidential computing. I also see there are other technologies which are crucial to ensure that the application is completely secure at each layer. So we say trusted enclave everywhere, right? But how this application will reach the trusted enclave? Are we securing this application when it goes till to the entry of the trusted enclave? That's also more important, right? That's where I see some of the technologies like homomorphic encryption, which is basically about computation of informations from the ciphertext directly without decrypting it. So that is one technology that is in industry more into the research, where they are trying to research whether it is possible to compute all informations that are required for any processing without decrypting the data. If we see here, we are still securing the data that is in use without decrypting it. So it actually provides a way to secure the data in use, which is the concept of confidential computing, right? And we see other technology that is zero trust architecture. So it is about providing the security at all levels. Basically, it is to prevent the inside and external threats. So that also plays a crucial role because at all layers of application we provide the attestation, authorization, everything to make sure before it gets into the trusted enclave, the data is completely secure, right? That is more important. So there are some more technologies. It is not so less to say in this, but one or two things that I remember now is like functional encryption is there, and there is something like multi-party data computation is there. So there are some more technologies. Like Carol mentioned, we even have some of the open source framework. One I know is Google Asylum, and the other one is Confidential Consortium Foundation, which is actually group of industry people come together and then work on coming up with an open source framework, which actually eases the development of applications that can run on the trusted execution environment. So I believe end-to-end security is possible with all of these technology together in place and not just with the trusted enclaves.
Thank you. So there are these host of technologies, frameworks, techniques, right? In the form of zero trust architecture, homomorphic encryption, trusted execution environments, and of course the machine level, process level, function level isolation that you are mentioning. So definitely a cutting edge solution to securing data in use. So we can basically conclude that confidential computing requires some amount of specialized hardware, right? Software and expertise in cryptography and security for that matter. Right? Nevertheless, it's a new technology and therefore we understand that it has several challenges, right? And some of them that I have read about are implementation complexity and lack of standards, so issues with regards to interoperability and also data privacy regulations, right? And some amount of technical limitations as of now. So on top of that, we heard from all of you, there are these multiple approaches and each with its own strengths and weaknesses. Imagine this can make it very difficult for adopting organizations to choose the right solution, right? So what are your thoughts on some of the implementation challenges and how cloud providers and adopters are together addressing this challenge?
I can take this. Okay. So let's first understand what are the key features which are needed for any industry to adopt the confidential computing. So I would consider the key consideration as first the hardware side, where the hardware that is being used for the confidential computing, it should be very secure. So more and more businesses are now moving to the cloud. They are moving all your sensitive data to the cloud. So this brings a challenge to secure more data, and nowadays the data has been intensified to a larger extent. So which brings a new challenge for the cloud providers to secure data. The second thing that comes up is the privacy pressure. So the different regulations like GDPR and CCPA, which I mentioned, so they are forcing the cloud providers to provide proper compliance regulation along with the cloud provider as well as onto the adopting organization, so that the data that is being used, it's secure. So considering this adoption techniques, we need to understand the industries that are actually moving towards the confidential computing. So there are different sectors which are actually moving towards it. It comes under healthcare services, financial services, then there are telecommunications and the media services. So if I talk in terms of healthcare services, the patient data is the most important sensitive data that for any of the healthcare organization we can consider of. This patient data, it is being the healthcare services, they send this patient data to different organization for diagnosis purpose, for the different data that they want to take it of, like let's say the blood report or any other diagnosis. So this data needs to be very secure. So confidential computing helps to secure this patient data for the healthcare services. Whereas if I talk in terms of the government services, so the confidential computing is helping the government to secure the national data, the election data that the government is maintaining. Whereas if I talk in terms of the telecommunication, they are actually securing the user location data. So wherever the user is, that location data needs to be saved. So for securing this data, telecommunication industry needs to be very careful. So they are using confidential computing for that purpose. Other than that, there are other industries which are also using this. They are one that I can think of is the manufacturing. They are actually creating secure designs so that they can protect their intellectual property. Considering all the industries that are actually moving towards the confidential computing, it's not that easy to cope up with. There are certain challenges that the confidential computing technology still faces because it is still evolving. So among that, the first that I would consider is the performance bit. Like not all the hardware currently supports confidential computing. So there are still some hardware companies which supports the confidential computing, but we need more for that. So another then, since we do not have that much hardware support, it also brings a performance hit. If we want to go for the confidential computing, we need to make sure that the skill set a developer has, it should be sufficient. Currently, the skill set that developer has, it's good for the traditional development. But when we talk in terms of confidential computing, we need to build a better skill set. And we also know that we are working with data. So the applications which are very data intensified, data workloads are increasing. So we need to make sure that the data is secure, because the performance hit is bringing a low into the latency and the speed. So these are some of the challenges that I still see the confidential computing is facing.
Yeah, so I think on one side there are these regulatory issues which require you to go for confidential computing. Let's say the HIPAA regulations in healthcare, or the GDPR, CCPA, like you were mentioning, which forces organizations to move towards confidential computing. On the other side, you talk about the skill set issues, uneven provision of this by the hardware providers, and the performance versus the security trade-offs. Is there anything more to add on the nature of adopting organizations and challenges?
Yeah, I would like to add to the pointers which Priyanka mentioned. So let me expand on the use cases, right? So say it's a healthcare institution. Now, yeah, as Priyanka mentioned, there's a lot of sensitive data. You have your treatment recommendations, diagnosis, blood reports, the patient records. So it's very important for these medical institutions to share this particular data for research and analysis. Now, since there is sensitive information, what they do is they share something called as limited data sets. Now, what are limited data sets? It's nothing but the entire data set, but it is stripped off all these patient identifiers. So, the limited data set goes out for analysis. But the problem here is that when it comes to analysis of some very rare diseases or rare conditions, it's not really beneficial because you need the entire data set for this. And this is where confidential computing comes in handy. You can simply share all the data and you don't really have to worry about the privacy issues. Now, in case of government agencies, you do have financial intelligence units. So these are the units which look into all of these, money laundering that goes around. So there could be some cross-border transfers, that could be some large transactions or, continuous repetitive cash deposits. So all of this data cannot really be shared entirely with these financial intelligence units because there is sensitive information, there's government data. So again, confidential computing to the rescue, because you can share all of this data and do not really worry about all of the sensitive parts in it. And you do have something called as multi-data modeling, multi-party modeling. So here, what the different vendors do is they pull in their raw data. So they put in their raw data, and this is used to improvise all the data models. So again, the vendors can simply put in their raw data and not really worry. Now, what is stopping their adoption? What are the challenges that we are having here? So as Priyanka mentioned, right, it's again hardware issue because it's not supported in all the CPUs, and you need your employees to be educated about this, right? Because confidential computing is a new terminology, so your employees need to know about this technology. They need to be able to build your application supporting this particular technology, and you also have performance issues. So see, in confidential computing, performance is not really significant. But if your application is data intensive, yes, you can, make out these small performance issues as well.
Okay. Thank you for reiterating on the skill set aspect. Seems like it is coming out to be quite strong on the need to build that skill set for confidential computing. And it's definitely heartening to see that, confidential computing paves way for some of those industries which have significantly sensitive data to migrate to cloud, right? And it's also interesting to hear of the developments in the usage of confidential computing for multi-party data sharing models, right? I think we are slowly crossing the peak of inflated expectations, and maybe more changes at the institutional level with regards to data sharing agreements and community-based open source development support for TEEs, the trusted execution environments, and probably some technological changes that make the adoption process more simplified, right? I think we can overcome performance overheads in the next few years, and we slowly help promote mainstream adoption, right? Now, while we are seeing the hype cycle of confidential computing, let us hear from you guys on what do you think about the future of confidential computing with regards to the players, the ecosystem of players, right? And how it's going to evolve in the next couple of years. Yeah, sure, Soumya.
Okay, so we had lot of challenges. Then surely we will have a future, right? We have to fix those challenges in the future for
Absolutely.
sure, right? So as Carol mentioned and Priyanka mentioned, right? Lot of challenges we see with respect to performance and scalability, which really has to be fixed in the future. And also I see, right, with respect to, we already started off with this combined effort from multiple industry people, as Carol mentioned that CCF is a community which is trying to develop together some of the solutions, right? So similar to that, something we need on where we can bring it to the container environments as well. So now if we see lot of workloads actually run on cloud, VMs and also container based environments, right? So we need to bring in some support at the container runtime level. So this trusted execution environment can be utilized by the applications easily. So we should bring in some built-in native support for trusted enclaves in the container aspects like Docker or Podman. So we can seamlessly use these applications as a secure applications, right? And other than this, what I can think of is like maybe we can also include this into Kubernetes. We can actually make this to deploy workload securely, and also we can do secure scheduling of the workloads. So all these can be possible when we are able to do this. What I see as a future for confidential computing, right, when we are able to integrate the trusted enclaves along with the cloud native platforms or modern ecosystems like Kubernetes, right, then we will not only end up with enhancing the security, but we are also moving towards on the innovation path across industries, right? Not just sticking to the security aspects and not just sticking to the modernization aspect. We are integrating both together, security with modernization, which will be a new innovation sector, I feel, for confidential computing.
Yeah, that's great to hear. Do you all agree? What do you foresee?
Yeah, definitely. So,
yeah?
so when it comes to the future, right? So we do have, so I spoke about Confidential Computing Consortium. So they're working on standardizing it. So, they want to ensure that there is open source tools and best practices implemented and standards across different industry vendors and across different platforms. And also, confidential computing has been there in CPUs for a very long time. And now it's also moved to GPUs. We know GPUs, they're used for your 3D graphics, your AI ML models, your scientific simulations, etc. So it's moved to GPUs, and right now in GPUs, it is supported for small to medium-sized models. And as per what I just read recently, the big players are also trying to implement it on large language models. And also, Gartner, as per its report in the year 2020, it coined this term confidential computing as one of the 33 key security technologies. And a lot of these market research and consulting firms do see a lot of rapid growth in this particular technology. So there's this one market research firm called as Allied Market Research. So they did analysis in this field, and they did provide a report. And as per that report, in the year 2032, the market share for confidential computing is predicted to be 184 billion USD dollars by the year 2032. And it's also predicted that from this particular year till the year 2032, it's going to see at least an annual growth rate of nearly 46%, which is like huge. You can imagine how big this particular technology is going to be in the near future.
Yeah. So, anything you want to add?
Yeah.
Priyanka?
So as Carol mentioned that since the share is going to rise by 2032 to 184 billion dollars,
Yeah.
it's a high time for the cloud provider as well as the adapting organization to get into this. With this, there comes a responsibility of the hardware industries also to build the specialized chips, because chips are the one that is the base, the foundation of the security. So I would consider for the future we need to take care of the hardware side also, as well as from the software side we need to build up a good skill set which can help the organization to move very fastly towards the computing. So.
Yeah. Okay, I can see a lot of positive, energy around these discussions. But just because we have a tool now in our hand, right? We have a hammer. Does everything seem like a nail to us, right? So, is it? Are there any cases or scenarios specifically where it is not necessary to go to confidential computing, right? How should? Is it an overkill in some cases? How do you suggest, managers make these decisions, right, in their business processes? Where do you draw that boundary?
Yeah, surely I want to take this
Yes, yes,
question.
yes, please.
So when AI became a buzzword, right, everyone wants to work on AI. AI, right? Whatever POC we want to do, first we will try with AI. Where it can be simply solved with simple solutions, but we'll still look for some AI options to put into it, so it will become a fancy, right? So that's how it happens. Whenever a technology becomes famous and it's spoken everywhere, people will start thinking only on that technology. They will not think on the requirements part. But always the technology is to support the requirement, and not because of the technology we bring up the requirement, right? So it should be the other way. Whenever we choose a technology, it is mandatory that we look for the requirement that is needed to use the technology. We should not use just because the technology comes and it became famous, okay? So I would say, like, only if we deal with sensitive informations which has to be protected, like Carol and Priyanka mentioned, right? More on patients' data in healthcare departments or financial sectors, or government data which has to be protected very securely. Yeah, I agree. It's very important to use confidential computing. But just whatever data that comes for free, that is available publicly, just we are going to put up a post onto your social media which needs to go for all this data security processing, authentication, authorization, attestation, everything all through that. But that doesn't make sense, right? More than the requirement, what is needed, we are spending our resources to compute this secure mechanism. Whenever an encryption comes in place, followed by it attestation will come, signing of a keys will come. So we are spending a lot of resources around the setting up the environment, but rather than looking onto the requirement side itself, right? So I would suggest if the application is a short-lived application, which is not going to handle any sensitive information, it doesn't make sense to actually use confidential computing, other technologies. Maybe we can go with minimal level of securities there, not to the level of trusted enclaves. That's what I feel, Lakshmi.
Yeah. So it's wonderful to hear about your views on confidential computing. I think I see a lot of industry interest and hype around this topic, and probably we also are going to see a lot of collaboration and cooperation amongst major players, providers in one side, then you have open source communities, generative AI companies, right? So that we develop standards, we develop interoperability and portability. And one last topic that I want to pick your brains on, I am coming from academia and we have all of you from industry. There is always this gap. You are working on cutting edge solutions. In the academic institutes, research is happening in silos. How do we bring these two on par so that fresh graduates who are out in the market really get a view of what's out there in the industry, what's currently happening with data privacy and security? We do have a lot of courses on these, but how do we get them equipped with the latest technological wherewithal, right, so that they are prepared for what they are going to see, right?
Sure. I'll take this. So, the institutions and the industry should work together. The industry should provide different learning courses onto the different computing technologies, whether it's cloud computing or confidential computing or anything related to the AI ML or the big buzzing words that we usually use. But it's not just only the buzzing words, but it's basically the tech world that is behind it. So there are many courses available online as well as onto the free also, and there are some courses which are paid. So institution must ask, they should even include it into the study itself, so that the new graduates or anybody who actually wants to get aligned with it, it becomes easy for them to get into this.
Yeah, any other views?
And also, I think there has to be collaboration between, the industry and the college itself. So, see, you just read about buzzwords, you cannot really, just go ahead and, sign up for that particular course. It's very important for the colleges to know what is happening in the industry, what is really happening, and then what are we actually working on. So, I believe workshops by these industries, and that's what, would help the upcoming graduates.
Yeah.
I can actually put in my point as well. So I had lot of things running in my mind when I came into industry, right? So how come they work on projects? How come it becomes a product? How come it becomes? Because when we see from a college or academia, right, we know only small projects that we work on that will result in a very small products and outcome. It is just a smaller thing. But when it comes to industry, though you don't work on the complete product, but you will be a part of it,
Especially.
a smaller part of it, but the outcome is bigger because you were in the process, right? So it is important to include the students into the process. That's what I feel is more required.
More immersion
Yeah.
into the industry.
We have internships with companies. Yeah, people get to come there, but we need this along the education. That is more important. So what I would suggest, that I feel like if it is there, it would have been better, is having workshops, industrial workshops. We have as they say IV visits, I guess, right? So similar to that, if we have something which is happening for all the students, not for selected students or something like that, so they get to experience the feel of how the industry works, what are the actual technologies that people work on the industry. So that gives them the confidence when they come into the industry, what kind of environment they can actually look for.
Thank you for your insights. Hope we'll get to implement these soon in our colleges, right? And I think we'll surely transition to an era of trust and transparency in data handling during computing, and we also probably are going to see more and more organizations migrating to public cloud without any apprehensions about privacy and security. It was wonderful sharing the stage with you all, and I think we have come to the closure of this panel. Yeah, thank you. I hope we are on time.
Thank you.
Yes.